Welcome back to our YouTube channel. So in today's video we are going to calculate the inverter size, the battery bank size, and the PV size. So our question states that we have devices, quantities, rated power, time of operation as it is stated by the table. So in our question we have 5 televisions, 2 upright fridges, 20 inside lights, 6 security lights, 1 borehole, 1 borehole pump, 1 booster pump, 1 microwave, and 1 washing machine. And 5 television have a rated power of 600 watts. Our upright fridges a rated power of 500 watts. Our inside lights has 10 watts. Our security lights have 60 watts. Our power have 750. Our booster pump have 400. Our microwave have 1500. Our washing machine is 400. And the time of operation of our devices, our televisions works 7 hours during the day. Our upright fridge works 6 hours during the day. Our inside lights works 12 hours during the day. Our security lights works 9 hours during the day. Since they are security lights, they are turned off in the morning and they are turned on back on in the night. Our power operates for 3 hours during the day. Our booster pump operates 4 hours during the day. Our microwave 1 hour during the day. Washing machine 4 hours during the day. Our night hours of operation, our televisions works 4 hours during the night. Our upright fridge works 5 hours during the night. Our inside lights works 4 hours during the night. Our security lights works 12 hours during the night. Our bulb works 9 hours during the night. Our booster pump works 9 hours during the night. Since the bulb will not be working, our microwave works 1 hour during the night. Our washing machine works 9 hours during the night. So the question says, assuming that the daily insolation of 6.31 watts, that's assumption number 1. Assumption number 2, the 3-day anatomy period. Assumption number 3, system voltage of 48 volts, and the day-old DOD efficiency of 80%, and the battery charge efficiency is 95%. So the question says, calculate the inverter size, the battery bank size, and the PV array size. So we are now calculating. In calculating, we have to remember the formulas. So we are going to write the formulas first. So our first formula is to calculate the peak power. Our peak power can be calculated as quantity multiplied by wattage or rated power. This is the formula to calculate the peak power. To calculate the surge power, we say peak power multiplied by 3. And peak power multiplied by 3 is known as the surge power. The surge power is there to allow the takeoff. As we start our appliances, they tend to draw more voltage and starts to regulate as it goes. So this is the allowance so that our appliances will not go over voltage or under voltage. So now after calculating the surge power, we have to calculate what we call night energy demand. Night energy demand can be calculated as peak power multiplied by number of night hours. After calculating the night energy demand, we have to calculate what we call day energy demand. The day energy demand can be calculated as peak power multiplied by total number of hours, which means we are now adding hours of during the day and hours of during the night. Now we want to create a table and fill our table. So the table will consist of a load, consist of quantity, wattage, day hours, night hours, peak power, surge power, night energy demand, and day energy demand. And our devices we are given by the question. We are given television, upright fridge, inside lights, outside lights which are security lights, a borehole, a booster pump, a microwave, and a washing machine. And we have 5 televisions, 2 upright fridges, 20 inside lights, 6 outside lights, 1 borehole, 1 booster pump, 1 microwave, and 1 washing machine. And those devices you have the following wattage or rated power. 5 televisions at 600 watts, upright fridge is 500, inside lights is 10, outside light is 60, ball 750, our booster pump 400, microwave 1500, and lastly our washing machine is 400. And this is given by the question. Our time of operation is divided into 2, day hours and night hours. So our daily hours, our television works 7 hours a day, upright fridge works 6 hours a day, inside lights works 12 hours a day, outside lights, since they are security lights, they don't operate during the day, so there will be 0. Our ball operates 3 hours during the day, our booster pump operates 4 hours during the day, microwave 1 hour, and our washing machine operates for 4 hours. During the night, our television operates for 4 hours, our upright fridge operates for 5 hours, our inside lights operate for 4 hours, and our outside lights operate for 12 hours. Our ball did not operate, our booster pump did not operate, our microwave operates 1 hour, our washing machine operates none again. So, calculating the peak power, surge power, night energy demand, day energy demand is calculated as follows. As we said earlier in the formula, to calculate peak power, we have to say quantity multiplied by rated power or wattage. So our televisions have 5 multiplied by 600, which is 3000 watts. Our upright fridge, 2 multiplied by 500, we get 1000 watts. 20 multiplied by 10, we get 200. 6 multiplied by 60, we get 360. 1 by 750, we get 750. 1 by 400, we get 400. 1 by 1500, we get 1500. 1 by 400, we get 400. Now we are done calculating our peak power for each device. So our surge power for each device is calculated as our peak power multiplied by 3. So 3000 multiplied by 3, we get 9000. 1000 by 3, we get 3000. 200 by 3, we get 6600. 3600 by 3, we get 1080. 750 multiplied by 3, we get 2250. 400 multiplied by 3, we get 1200. 1500 by 3, we got 4500. And lastly, 400 multiplied by 3, we get 1200 again. Now calculating the night energy demand. Calculating the night energy demand, we just have to calculate to multiply the peak power multiplied by number of night hours. So this will be 3 by night hours. Our television works 4 hours during the night, and it has got a peak power of 3000. So 4 multiplied by 3000, we get 12,000. And 5 multiplied by 1000, we get 5000. 4 multiplied by 200, we get 800. 12 multiplied by 3600, we got nothing. Why? Because they don't work during the day. Now we have to move on to calculate for the ball. The ball doesn't work during the night, so we have nothing. The booster pump doesn't work during the night, we have nothing. And microwave works 1 hour, so we have got 1500. And our washing machine doesn't work during the night, so we got nothing on that. Calculating the day energy demand. The day energy demand, we have to add the total number of hours, day and night hours, and multiply it by the peak power. So we have 11 hours in total of operation of our television. So we say 11 multiplied by 3000, we get 27,000. We say again, we have 11 again multiplied by 1000, we got 12,000. For the second one, we got 2000. Do the maths, we got 4320, 2250, 1600, 3000, 1600. Now that we filled our table and we have made our work a lot easier, so we have to move on. We have to find the summation of peak power, surge power, night energy demand, day energy demand. So in calculating the summation, we just have to add everything. So in peak power, we have to say 3000 plus 1000 plus 200 plus 360 plus 750 plus 400 plus 1500 plus 400. We got the total peak power of 7610. Then calculating the surge power, we do the same thing. We add the totals, we get 39,030 watts. Now we have to calculate our night energy demand, total night energy demand. Do the same thing, just take it from the table, we add, and we got 19,300 watts. And finally, we have to calculate our day energy demand. Doing the same process, take them from the table, add them, and we got 53,970. After we have calculated the summation of all the power, we now have the total peak power, we now have the total surge power, we now have the total energy demand, we now have the total day energy demand. We can now move on calculating our inverter size, because we have all the necessary information to do so. So calculating the inverter size. The inverter size can be determined by the following formula: the total peak power multiplied by Safety factor. Our Safety factor ranges from 1,2 up to 1,5. So I decided to take 1,2. So the total peak power is 7,610. So we multiplied it by 1.2. We got our inverter size being 9,132 watts. So this is the inverter that is needed to operate a system of a given information, of a given devices. We may need this size of an inverter, but due to our market, this type of inverter may not be available unless we have go for custom made. But what we can do, we can just take the inverter that is just after our value, which is 10,000 kVA. So our inverter size will be 10 kVA. So after that, after we have finished calculating our inverter size, we have to know, just for context, we have what we call inverter rating ranges. Inverter rating ranges can be used in determining the battery bank size or the battery capacity to consider. So we have an inverter that ranges from 1000 watts all the way up to infinity. So our 1000 watts inverter up to 1500 watts inverter. This inverter may need what we call a 12 volts battery. You can't use a 48 volt battery on a small inverter like 10,000 watts. From 1500 to 3500 to 3000, we may use 12 volts. From 3000 to 5000 and above, we may use 48 volts. Then, after we have done this, we now have a knowledge on how to calculate the inverter size. We may now need to move on calculating what we call the battery bank size. The battery bank size. In determining the battery bank size, the capacity for night hours is needed. Now, how to calculate the capacity of night hours? The capacity of night hours can be calculated as night energy demand over system voltage. Since our voltage is above 5 kVA, we may use 48 volt battery. So for context, to have those units of amps, we may recall that P is equal to voltage times current times time. By substituting those ones, we may achieve those units. So we got our total night energy demand is 19,300 over 48 volts. V and V cancels each other. We're left out with 402 Ah. this is the capacity required. So now, when you are determining your battery bank size, you also have to consider the battery selection, as there are many types of batteries out there and which have got different types of efficiency. So number one, we have lithium battery. Lithium battery works differently from the gel battery, from other types of batteries. So on number two, we have the gel battery. So this is the pictorial view of our lithium batteries, and this is the pictorial view of our gel batteries. So after that, you have to calculate and determine which battery to use. Let's say we will calculate everything. We will calculate the lithium battery required and the gel battery, then determine what we want according to the efficiency of our batteries. Number of lithium batteries required. Number of lithium batteries can be calculated as, you may start calculating the number of batteries in series. Number of batteries in series can be calculated as system voltage over selected battery size. Our system voltage is 48 volts. Our selected voltage is 48 volts. So we have one battery in series. Then we have to calculate again our battery in parallel. The battery in parallel can be calculated as a required capacity over selected capacity multiplied by the depth of discharge, or the DOD. So let's say, for example, we have selected a 48 volts 100 Ah lithium battery with a depth of discharge of 80% as stated on the question. So number of batteries in parallel will be 402 Ah over 100 multiplied by 0.8. We will get 5 batteries that are connected in parallel. So our battery array will be as follows. This will be the number of batteries, number of lithium batteries if you decided to use lithium batteries. These are the number of lithium batteries that you require. So we have what we call the battery array. The battery array can be used to determine how many batteries in total do you need. So it can be found as parallel battery multiplied by series batteries. Then you get the total. So we got 5 parallel batteries multiplied by 1 battery in series. We've got 5 batteries. So if we decided to use lithium batteries, which are 48 volts 100 Ah capacity, we have to use 5 batteries, only 5 batteries. So 5 batteries will be selected if we consider using lithium batteries. Now we are moving on to gel batteries. What if we want to use gel batteries? If you want to use gel batteries, the procedure is the same. We have to calculate the batteries in series first. Batteries in series, we have to say system voltage over battery voltage selected, which is 48 over 48 volts. We get 1 battery. Then batteries in parallel. To calculate batteries in parallel, we just use the same formula. Required capacity over battery selected multiplied by surface of DOT. But we have to remember that for gel batteries, the DOD is 50%, not more than that. So they are less efficient. But let's take, for example, we can't take 50%, let's take 40%. So number of batteries needed will be 402 over 100 multiplied by 0.4. Since our battery is 100 Ah and 48 volts. So if you do the math, we get 10 batteries. We get 10 gel batteries. So here's the thing. If we decided to use the lithium batteries, we will use for only 5 batteries. But if we decided to use the gel batteries, we will use 10 batteries. So for context, if we have small space for our battery storage or for our battery, we have to go for lithium batteries, as they may need small space as compared to gel batteries. So this is the end of our video. See you in the next video. Thank you.